Hi everyone, let's look at the lowest common ancestor problem of a binary tree. A lowest common ancestor is a node from which the paths diverge for any two given nodes for whom the LC is required. So for example, in the first binary tree, the lowest common ancestor for 2 and 9 will be 6, because here from 6 the path diverges for these two nodes. For the second example, the lowest common ancestor for 6 and 13 will be 3. And in the third example, the lowest common ancestor for 8 and 7 will be 8, because if one of the node is a parent to another, then that node will be the lowest common ancestor. So to solve this problem, there are multiple approaches. One is that we store the paths from root to both the given nodes whose LC is required. We then traverse the stored paths and return the node just before we find the first mismatch. This solution is not memory efficient. So let's look at the another approach better than this. In this approach, we search for either of the two given nodes starting from the root node whose LC is required. If anytime any of the node is found, we return that node to its parent. Anytime any node gets a not none node from the left side and the not none node from the right side, then that node will be the LCA and it returns its node value to its parent. So next we'll see how this approach will help us find the LCA in these three given binary trees. Let's see how to find the LCA for 2 and 9 in the example 1. So here we'll start from the root. We'll search if 2 or 9 is present in the root node or not. So root is 3, which is not either equals to 2 or 9. Then we'll expand our search and we'll go to the left side. Here we'll reach 6, which still is not equals to either of the two nodes. So again we'll go to the left side and we'll reach 2. So here 2 is equals to one of the values of the given nodes. So if we have found that node, will return that value to the parent. So now we'll search in the right side of the 6. It will go to 15, which is not equals to either of the nodes. Then we'll go to the left side of the 15, which is 12, which is again is not equals to either 2 or 9. And this node is a leaf node, so at the end it will return none to 15. Now it will go to the right side of 15. So it will explore to the right side. Here we have found 9, which is equals to one of the values. So it will return 9 to 15. So now the 15 won't be an LCA because one of the side is returning none and one is returning 9. So what 15 will do, this node will return the non-none value to its parent. So 9 will get returned to 6. So now 6 has got 2 from the left side and 9 from the right side. So 6 will know that it's the LCA for both these values. Now 6 will return itself to the parent. Now 3 won't know whether it's the LCA of not, because it still has the right side to explore. So now we'll go to the right side of the 3. We'll look that 8 won't match any of the values. Then we'll go to the right side of the 8, which is 13. It again won't match any of the values. We'll go to the left side of the 13, which is 7, which is not either 2 or 9. So it's a leaf node. It will return none. So 13 will again return none, and 8 will return none as well to 3. So now 3 will know that it has got 6 from the left subtree. So left subtree should have got the LCA. So 6 will be the LCA for 2 and 9. Now let's look at the second example. Here we'll find the LCA for 15 and 8. So we'll start from the root node. 3 is not same as 15 or 8. We'll go to the left side of it. We'll reach 6, which is still not same as 15 or 8. We'll go to the left side of the 6, which will be 2, which is still not equals to either 15 or 8. So as this is also the leaf node, it will return none to its parent. Then we'll explore the right side of the 6. We'll reach 15. So it is equals to one of the node, so it will return instantly the 15 to the parent node. Now 6 will not be an LCA because one of the left side of it is returning none and the right side of it is returning 15. So what 6 will do is it'll return the 15 to its parent. Now 3 won't know whether it's the LCA or not, because still we have the right side of 3 to explore. So we'll go to the right side of 3, we'll reach 8, which is equals to one of the values. So it will stop and return 8 immediately. So now 3 has gotten 15 and 8, the not none values from the right side and the left side. So 3 will return itself as an LCA. Let's look at the last example. Here we'll find the LCA for 8 and 7. So we'll follow the same approach. We'll start from the root node 3. We'll see whether it's equals to 8 and 7, and we'll do it recursively for the left side of the 3. So here we can see that 8 and 7 is not in the left subtree. So the leaf nodes will return none and will propagate this none value to the root node. Now we'll expand our search and we'll look for the nodes in the right side of the 3. So we'll see that 8 is either equals to 8 or 7 or not, which it is. So we'll stop and return 8 immediately to the parent node, which is 3. So now 3 will get to know that the LCA is present in the right side of the 3, and it will return 8 as an LCA. So 8 will be the LCA for 8 and 7. So next we'll see how to do it in terms of code. Here's the code for the LCA. The first condition is the base case. We will just return none if the root is none. Next, if root is either equals to one of the node for which we are looking for LCA, it will just return that node. And this condition will also cover that situation where one node is the ancestor for the another, so it will return that node. So after that we'll recurse the left subtree and the right subtree, and if we've got not none values in the left and the not none values in the right, we'll just return the root, which will be the LCA for them. So if that condition did not met, that means we have got either only the left node which will return the not none value, or either the right node which will return the not none value. So if left none is not none, we'll just return the left LCA, or else we'll return the right LCA. So this is just the simple code for the LCA, which has the time complexity of ON. So yeah, that's it. Thanks.